Hi guys. So today we are learning about isotopes and what they are. If we go back to the previous slide here, we know that the mass number is what's in the nucleus, which is the protons and neutrons. So all elements of the same kind, so for example, if you pick carbon, um, most of the time they have just normal carbon by itself would have the same number of protons, neutrons as each other. But sometimes that can change. Sometimes the number of neutrons can change between these elements. So that's what isotopes are. So isotopes, all atoms of the same element have the same number of neutrons. Sometimes the mass of the element, sometimes the same element can have a different mass. This is because the number of neutrons change. So if we look at this, let's focus on this diagram here. So there are actually three types of carbon. You've got the normal carbon here, which is what we find in the periodic table. It has 6 protons and 6 neutrons in the nucleus, and that is the mass number. So if you look back onto the periodic table, it has a mass number of 12. Carbon-13, the number of protons stays the same, still 6, but it has 7 neutrons, so it has 1 extra neutron. And remember, neutrons are neutral, so it doesn't actually impact the charge in any way. So it has 7 neutrons, so it's added 1. 6 plus 7 gives you 13. That's why it's called carbon-13. Carbon-14, still the number of protons remains the same. Now it has 2 extra neutrons to what it was originally. It has 8 neutrons, which will give a mass number of 14 because 6 plus 8 is 14. These three elements, it is still carbon. However, these are isotopes of each other. What that means is it is the same element, but they are different because of the number of neutrons. So the original one has 6, the next one has 7, and the other one has 8. It's still carbon, but because the number of neutrons are different, they are known as isotopes of carbon. So carbon-12, this is the most stable. That's what we see everywhere, what we're made of. Protons and neutrons are held very strongly together. Carbon-13 has 1 extra neutron. Carbon-14 has 2 extra neutrons. Because now it's getting more neutrons, it's becoming like it's further and further away from the most common one. It is becoming radioactive and unstable. And what that means is carbon-14 will break down naturally. So the more different you are from the original element, the more radioactive and unstable you are. So what you need to know is that isotopes of an element will have a different number of neutrons. So remember, this one has carbon-13 has an extra neutron, while carbon-14 has 2 extra neutrons. So what it means to be stable or unstable. So stable means that the protons and neutrons are held strongly. If it's unstable, protons and neutrons are not held strongly and it will become radioactive. So in the nucleus, if the protons and neutrons aren't held together, it becomes radioactive. The next slide is showing you just a summary again. So this is just a comparison of two different elements. So this is carbon. So carbon-12, 6 protons, 6 neutrons, it's stable. Carbon-14, the protons stay the same. That's very important. The protons won't change. It is the neutrons that change. So carbon-14, these are isotopes of each other, and it is radioactive. Uranium's another example of isotopes. So uranium has 92 protons, but one has 143, which is that's a radioactive one, but the stable one has 146 neutrons. So whatever you see in the periodic table, that is its stable form. Um, if the neutrons change, which means the mass will change, that means it will become more radioactive. So I want you guys to pause this video and I want you to fill this out without looking at the slides before, and add this to your OneNote. Alright, so we're going to continue. So there are a lot of types of radioactivities out there. So natural radiation is radioactivity emitted from matter without energy being supplied to atoms. So there aren't any energy given, so it's just naturally happening. Artificial radiation, it is made by bombarding the atom with neutrons and protons. So there's obviously some kind of change happening. And nuclear radiation, it is made by, same thing, made by bombarding at the atom with protons and neutrons. And there are three types of nuclear radiation: alpha, beta, and gamma. And these three things you need to be aware of. Okay, so nuclear radiation, it is a spontaneous breakdown of an unstable atomic nucleus. So we talked about before, like isotopes, they are unstable because the number of neutrons and protons, they're not bound together strongly, which will make it unstable. So when it's unstable, it will start to break down. When it's breaking down, it would release energy and matter from the nucleus in the form of radiation. And there are three types of radiation you need to know. So there's alpha, like this, gamma, and beta. So there are three types. Okay, so the first particle, or the first type of radiation, is the alpha particle. So let's focus on this first. So this is a helium atom. The helium atom has 2 electrons, it has 2 protons, and 2 neutrons. So the alpha particle is very similar to the helium atom. This is what the alpha particle looks like, just the nucleus. The alpha particle will have 2 protons and 2 neutrons. That's what an alpha particle is. So, as said in the second dot point, this is an alpha particle. It has 2 protons and 2 neutrons. So if we just look at this particle, we know the protons are positively charged and the neutrons don't have a charge. So that means there aren't any electrons. So this is an alpha particle. Because there aren't any electrons to balance it out, it has 2 positive charges, which means it gives this entire thing a positive charge. So the alpha particle is positively charged. So what's happening is, let's say you've got this nucleus here. It's super unstable and it's about to break down. As it's breaking down, it releases an alpha particle. This alpha particle has 2 protons and 2 neutrons. Remember, the alpha particle, because it has no electrons to balance it out, it is a positively charged particle that is being released. So it's positively charged, there are no electrons to make it neutral. It can't travel through particles easily. So this particle, it can't even travel through paper. But if you do breathe it in, it does cause some serious damage. So that's what you need to know about alpha particles. So if an isotope, or if you've got an unstable element, it can release an alpha particle. An alpha particle has 2 protons and 2 neutrons, therefore giving it a positive charge. Beta particle. So beta particle is similar to an electron. So remember that the electron has a negative charge. So what that means is, for example, this carbon here, carbon 14, which is unstable, it would start breaking down and release a beta particle, which is similar to, it's very small in mass and it has a negative charge, which is why we say that it's similar to the removal of one electron. that is beta particle. So alpha particle was a positively charged particle. Beta, on the other hand, is a negatively charged. Gamma ray is actually not the release of any particles, but it's a burst of energy. So what happens first is you've got an element here that's unstable. It's released after alpha and beta particles are released. So first thing, the alpha particles are released, and then it will start to release the beta particles, and then it will start to release the gamma radiation. This is at the speed of light. It is highly penetrating, so it can go through a lot of layers, which I'll go through in a second. But it can be stopped by thick concrete or lead. So remember that the alpha particle could not even go through paper, while gamma rays, it can, but when it comes across concrete or lead, it will be stopped. So this is a summary. So you've got this isotope. It's very unstable. It's starting to decay. It will release an alpha particle first, which is similar to the helium nucleus. Remember, it's got the positive protons and the neutrons. The beta particle, which is an electron, and the gamma radiation, which is not a particle, it's just a ray. This picture shows you kind of what each radiation can go through. So alpha particle can't actually go through paper. The beta can go through paper, but it can be stopped by aluminium. And gamma can go through all three, but it's stopped by lead. So gamma is the most powerful. So this is just a summary going through the charges of each one, the mass, the speed, how fast it goes through, the penetrating power, and what's most dangerous. So this is also a very good table that summarizes what we've just learned. Okay, guys, so hopefully that makes sense. And the next topic will be on half-life.